In example 1b, we are asked to multiply the expression sine of theta over 1 plus the cosine of theta by the expression 1 minus cosine of theta over 1 minus the cosine of theta. Okay, so we're just going to multiply these two expressions together. Okay, so I'm going to go ahead and write this down. Okay, when you multiply, you can multiply in either order, so it doesn't matter which expression goes on the left and which one goes on the right. I'm just going to write down sine of theta over 1 plus the cosine of theta. Okay, and I'm going to multiply that by 1 minus the cosine of theta over 1 minus the cosine of theta. Okay, all right, so we're really multiplying fractions here. So to multiply fractions, you need to multiply across the top and you need to multiply across the bottom. So this is going to be sine of theta times, and I'm putting parentheses here because this expression over here in the numerator of the second expression, it has two terms. Okay, so you're going to have to distribute here. Okay, so you need to put this in parentheses. So it's going to be parentheses 1 minus the cosine of theta. Okay, in the bottom, you have on the left expression, the denominator here, it has more than one term. So again, you need to put it in parentheses. It's going to be the quantity 1 plus the cosine of theta times the quantity here in the denominator on the second expression. You need to put it in parentheses as well, okay, because you're going to have to do some distributing here, okay? So you're multiplying the quantities in the numerator together and you're multiplying the quantities in the denominator together. That's how you multiply fractions, okay? All right, so let's work in the numerator first, okay? So you have the sine of theta times the quantity 1 minus the cosine of theta. You're going to have to distribute this sine of theta, okay? So we're going to end up with sine of theta minus the sine of theta times the cosine of theta, okay? In the bottom, okay, you're going to have to FOIL it, okay? You're going to have to FOIL it, okay? So you need to multiply the first terms together. 1 times 1 is 1. Then you're going to have to multiply the outer terms together. So 1 times negative cosine of theta, that's going to be minus cosine of theta, okay? Then you're going to have to multiply the inner terms together. So cosine theta times 1 is going to give you plus cosine of theta. And then you need to multiply the last terms together. So cosine of theta times negative cosine of theta, that's going to be minus cosine squared of theta, okay? All right, so that is how you FOIL out the bottom, okay? If you notice what happens in the denominator here, you end up with a minus cosine theta and then a positive one. They cancel out, okay? So the bottom is just going to be 1 minus the cosine squared of theta, okay? All right, so we need to simplify. Okay, let's clean up what we have. We have sine of theta minus sine of theta times the cosine of theta in the top. The bottom is just 1 minus cosine squared of theta, okay? We need to keep going. You want to get this as simple as you can, okay? So in the denominator, okay, you have 1 minus cosine squared of theta. That is the same thing as sine squared theta, okay? Reason being, remember your Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1, okay? So if you subtract cosine squared theta from both sides, you get that sine squared theta is the same thing as 1 minus the cosine squared of theta, okay, which is the quantity you have in the denominator, okay? So 1 minus the cosine squared of theta is equivalent to the sine squared of theta, okay? So that's why I made that replacement in the bottom, okay? The top is sine theta minus sine theta times the cosine of theta, okay? In the numerator, okay, both terms contain a sine of theta. So that's common to both terms. So you can go ahead and factor it out. Okay, so I'm going to factor out a sine theta from the top. That is going to leave me with 1 minus the cosine of theta in the numerator, okay? And remember, If you're factoring something, you can always check yourself. Did you factor correctly by multiplying it back out? Okay, if you distributed this back, this would be the sine of theta minus sine of theta times cosine of theta. Okay, so that's the numerator. Okay, the bottom is sine squared theta. Remember, that's the same thing as the sine of theta times the sine of theta. Okay, and then you end up seeing that there's a sine theta in the top. It cancels with one of them in the bottom. Okay, so the whole expression simplifies here to be 1 minus the cosine of theta over the sine of theta. Okay, all right, now the directions here are vague. It just says multiply this expression by the other expression. Okay, so we did that. Okay, you could stop here. Okay, remember in example 1a, the direction said to rewrite everything in terms of sine and cosine. Okay, we don't have that stipulation here, but if you did, this would be your final answer. Okay, this is acceptable as a final answer. Okay, but you can also go a step further. Okay, with trig, you're going to see, because there's so many different identities, there's several ways to write an answer and have it be correct. Okay, if you wanted to go further here, because again, there's not that stipulation that your answer has to contain only sines and cosines, you could break up this fraction. Okay, the correct way to break up a fraction is to take every term in the top and divide by the entire denominator. So you could do 1 over the sine of theta, and then keep the minus sign in the middle, and then do cosine of theta over sine of theta. Okay, and then this would simplify. We know that 1 over the sine of theta is equivalent to the cosecant of theta, minus cosine theta over sine theta is going to be the cotangent of theta. Okay, so this is another way you could write the final answer. Okay, so these two things are equivalent ways of writing the answer. They look completely different, but they're both correct answers. Okay, they are both the result of multiplying that first expression, sine of theta, over 1 plus the cosine of theta by 1 minus cosine theta over 1 minus cosine theta. Okay, so either one of these would count as the final answer. Okay, I want to mention one thing about this quantity we multiplied by. Okay, we're done with the problem, but I want to explain something. Okay, if you go back to the original problem and you look at this quantity we multiplied by, okay, 1 minus cosine of theta over 1 minus cosine theta, okay, we have some quantity divided by itself. So this thing is really equivalent to 1, okay? So we were really taking this original expression and multiplying it by 1, okay? Something equivalent to 1, okay? That is going to be allowed when you're establishing these trigonometric identities, okay? Because you're basically taking this original expression, sine of theta and 1 over sine of theta over 1 plus cosine of theta, and you're trying to convert it into something equivalent. Okay, so 1 minus cosine of theta over sine theta and cosecant theta minus cotangent of theta are equivalent expression. Okay, so this is an expression, sine over theta, sine theta over 1 plus cosine of theta. It is an expression. It is not an equation. Okay, so since you're not dealing with an equation, you can't, you can't apply that rule, whatever I do to one side, I can do to the other, okay? When you have an expression, you cannot change the original expression. You have to work with that expression. So essentially multiplying it by 1 does not change the original expression, okay? So again, we took this original expression, we multiplied it by 1, okay? This piece is equivalent to 1. It does not change the original expression, okay? This allows us to convert the original expression into something that looks different, that is equivalent, okay? Now, this quantity, 1 minus cosine of theta over 1 minus cosine of theta, which is equivalent to 1, it has a special name, okay? It is called the conjugate, okay? Because if you look at the original expression and you look at its denominator, the denominator is 1 plus cosine of theta, okay? this fraction is related to the denominator of the original expression, okay? Instead of 1 plus cosine of theta, it's the exact same thing, except we change the sign in the middle. Instead of a plus, it's got a minus, okay? So that is the conjugate of this denominator, okay? We just took the same terms, we took the 1 plus cosine of theta, okay? You basically write it down over itself, but the difference is you're changing just the sign in the middle, okay? So if you put that quantity over itself, okay, that is something equivalent to 1, okay? And then what happens here, if you multiply the denominators together, okay, it's going to allow you to kind of change up that expression, okay, and get something equivalent, but it looks different, okay? So that is what this conjugate is, okay? It can be very helpful when you're establishing an identity to multiply by the conjugate, okay? So I'll give you, real quick, I'll give you another example. So say you had, I don't know, let's say we had, well, let me see, what did I have here? Let's say we had the tangent of theta over 1 minus, I want to make sure I give you something different, 1 minus the sine of theta. Okay, if you had that fraction and you wanted to multiply by the conjugate, you would multiply by a fraction, okay? The fraction has to be a quantity divided by itself, okay? You're going to take the denominator, you're going to keep the 1 on the left, the sign on the right, and you're going to change the sign in the middle. Instead of a negative sign, it's going to be a positive sign, okay? So this would be multiplying by the conjugate, okay? And you may see that as we go through this process of establishing identities.